Okay, so let's look at an introduction to calculus. The first thing we're going to look at in calculus is something called rates of change, and you would have come across this before. So what rates of change are all about is measuring, comparing two different units and seeing how those quantities change. Now, you would have done this before, but let's look at a simple example to start off with. Here I have a distance time graph where my y-axis is distance, if I put distance measured in meters, and my x-axis is time, and let's say that's measured in seconds. And what this line represents is it represents an object travelling along and its distance away from a fixed object every second. Okay, so at time 0, the object is 0 meters away from a starting point, and at time 5, well, okay, I can't read quite what the value is at time 5. Maybe it's something like 20, but at 4 seconds later, it is 16 meters away from this particular object. Now, what we're going to do is we're going to work out a particular rate of change. We're going to work out its speed. So to work out speed, we need to take a distance, which is measured in meters here, and divide it by a time, which is measured in seconds. So, well, let's take 2 points on the graph, and if you look at this graph in particular, it's a straight line. That means the object must be moving at a constant speed, and we'll show why that is in a moment. Well, let's take 2 points on our graph. Well, at time 0, it's 0 meters away, and at time 4 it is let's see, 16 meters away from this particular object. So what we have is that the distance, okay, travelled is from 0 to 16, so 0 to 16, okay, so that's the distance the object's travelled from 0 to 16, and the time it's taken is 4 seconds, okay, and so if we divide those two, distance divided by time, we get 4, and that will be 4 meters per second, and that's the speed. And well, and the speed is constant. That means if we take another 2 points, let's see if we can find two nice points. Let's pick this point here and this point here. Right, 1 second the object is 4 meters away. Okay, 4 meters away, and at 3 seconds the object is 12 meters away. So if we join these two up, make a nice little triangle here. Right, what distance has he travelled in this length of time? Well, let's see, that's 2 seconds across from there to there, and this distance here that's travelled, sorry, let's see, is 4 to 12. Well, that's a distance of 8 meters in 2 seconds, and if we take the distance travelled here, which is 8, and divide it by 2, again we get 4. The speed is 4 meters per second. So it's constant because the line is a straight line here, and it doesn't matter which 2 points on this particular line you use, the speed will always be the same. But what we've worked out here is a rate of change. We're comparing two different quantities here, meters and seconds, how far this object travels in meters every second. So it travels 4 meters every second. But what we've also done is we've worked out the gradient of this line. And if you recall how you work out the gradient of a line, you take 2 points on your line. Okay, so let's say here's our line, and you take 2 points on the line, and you draw a right angle triangle, and you work out the vertical step. So that distance there is the vertical step, and then this is the horizontal step. And then to work out the gradient, you do the vertical, if I just put vert, and divided by the horizontal. So you do the vertical step divided by the horizontal, and that's what we've done here. 8 divided by 2 is 4, and then here we've done 16 divided by 4, which is again 4. So effectively we worked out the speed or the rate of change, but we've also worked out the gradient of this particular graph. Now let's look at something a bit more, a little bit more challenging than that. Okay, here's a different object, and you can clearly see, because this graph is curved, that it's not travelling at a constant speed. But let's say I wanted to work out an average speed, okay? And let's say someone said to you, work out, okay, well, I forgot to label my axes. Alright, let's label them again. So again, we're dealing with distance in meters going up, and then time in seconds going along, right? Okay, and so let's say someone said to you, work out the speed from 3 seconds of this object, 3 seconds from the 3rd second to, let's say, the 8th second here. Okay, 8th second here. So I want to work out the average speed, okay? The average speed from 3 seconds to 8 seconds. So we're not concentrating on time 0, we're just saying from, right, from time 0, forget about that. When you spot the object 3 seconds later from where it left off, and 8 seconds later, what's its average speed between those 2 points? Now if we want to do that, because this graph is curved, well, we can't really work out the gradient somewhere in between. What we have to do is, if we want to work out the average speed, we join these two up with a nice straight line like this, okay, and we'll make a right angle triangle, okay, with this orange line, and I'll go across and up, and I'll work out, well, the distances, well, the number of units going across. So from 3 seconds to 8 seconds, well, that's a gap of 5 seconds here. So this is my horizontal step, right? Okay, and then my vertical step, so how far has the object travelled within that 5 second time frame? Well, at 3 seconds, it was 20 meters away from its object, and then 5 seconds later, well, at 8 seconds from this point, 8 seconds, it's 100 meters away from the object. So that vertical step is a distance of 80 meters. So in that 5 seconds, it's traveled 80 meters. It hasn't traveled at a constant speed because the graph is curved, so we're not really caring about this curved blue bit really now. But we want to know what the average speed from 3 to 8 seconds is. Well, again, if it's traveled 80 meters in 5 seconds, all we need to do is do 80 divided by 5, which is 16. 16 meters per second. Okay, so that's his average speed. Well, we don't know what the exact speed is every second after that third one there. It could be, well, we won't know just yet. But we know what the average speed is from those 2 time intervals. So we've worked out the gradient joining these 2 lines as well, these 2 coordinates on my line, and we've also worked out the average speed as well. Okay, so calculus and rates of change, they're really linked together, and calculus is really about working out these changes in quantity and comparing 2 different units. So later on we're going to look at some trickier examples to do with these curved lines.